Hi, and welcome to Introduction to Material Editor Quick Start video for V-Ray for Revit. In this second video about materials, we'll go over creating and editing materials in Revit using the standalone V-Ray Material Editor, building on our previous Quick Start video that introduced materials. Launch Revit. Here we're using 2017, and load the project file materials2.rvt from the downloaded assets from the tutorial's webpage linked below. You'll be able to use this project with Revit versions 2015 through 2017. With the project loaded, click the V-Ray tab and set your active view to Render 1. Leave Quality to Draft, and for resolution, select Crop Region and select Printer with a DPI setting of 96. Click Render to see what the project looks like. The first thing to address here is how transparent this glass material looks on the table. It just disappears into the background. So let's create a new one in the V-Ray Material Editor. Now, as we saw in the previous Quick Start video, you can launch the Material Editor through the Material browser. However, this is for existing materials in the project. Creating a new material from scratch requires that you launch the Material Editor through the app itself. Navigate to where you installed V-Ray for Revit, which is usually on your C drive at the path shown here, and then double-click to launch vrmateditor.exe. To start a new material, click File and choose New, and you're presented with a new material to edit. The Editor dialog is divided into two tabs, Basic and Advanced, giving you access to various parameters to control. Let's go back to the Basic tab. Rename the material to something more descriptive to the object it's made for. Table glass should do it. The Material Editor has some preset material types to choose from, and it's currently set to Generic. So click here for a pull-down menu and select the Glass type. By default, the glass material is a tinted glass, as you can see here. Let's create a blue-greenish glass like a tempered glass. We'll do that by changing the fog color. In short, fog color defines the tinting that you see in the glass. The lighter that color, the less tinting you'll notice in the glass. And the darker that fog color, the more dense tinting you will see. To select a color, click on the swatch itself for a color palette dialog. Choose one of the basic colors or use this area to define your own color. Typically, you'd want to set a light fog color, so set a cyan color with a brightness or luminance value of 190. Click OK when you're satisfied and you'll see the preview swatch update. Click File in the menu and select Save As to save the material. I'll save this material to the same folder where I downloaded the tutorial's assets. In Revit, click to open the Material browser. In the text filter box at the top, type in Table and the material currently assigned to the table is shown. We want to change this out to the one we just made, so click on AutoGen and select V-Ray Material. Navigate to where you saved the table glass material, which is called Table Glass VR Mat in our case, and go ahead and open it. Open the frame buffer, or VFB, and select a region around the glass table to the edge of the frame, and then click to render to see our handy material work. Now, not only has the color changed in the glass, but also the light passing through the glass has changed as well, which affects the shadow. Now, turn off Region Render, and we'll go ahead and change out the floor to be a polished concrete. Go back to the Material Editor window and make a new material through the File menu. Name the material Polished Concrete. This time, we'll leave it as a generic material type in order to explore the parameters and how they work. Basically put, the diffuse color is essentially the base color of a material. Drag the slider to change the value of this gray color brighter or darker, or click the color swatch itself to define a different color as we did before. This time, however, we're going to use a bitmap image file instead of a solid color. Click the map icon here. This bar, where it currently says None, is the Texture Editor button, so select that and you'll see a wide range of textures available. Click on Bitmap to allow us to select an image file from the File dialog that opens. Navigate to the concrete diffuse.jpg file that you downloaded with the tutorial assets and open it. Now, taking a look at the JPEG, this square of concrete looks to be about 10 feet by 10 feet. So make a mental note of this for when we return to Revit later in the tutorial. Click a Back button to return to the material, and the materials preview updates to show the concrete texture that we added. Since this is a polished concrete, we're going to need some reflection to it. The brighter you create this value, the more reflective the surface will be. We'll set ours almost to the very end of the slider, just short of pure white for a nice strong reflection. The refraction, fog color, and IOR settings, for the most part, deal with transparent or translucent objects like glass, so we won't need to adjust those, but we will adjust the glossiness value. This parameter adjusts how sharp the reflection shows up in the surface when you render it. With a value of 1 for glossiness, you get a very sharp, perfect reflection. Adjusting to make the glossiness value lower makes the reflection blurrier. Let's set this to 0.85 for a slight blur to the reflection and its highlights. Save your material, polishedconcrete.vr matte. In the material browser, start typing in wood and you'll see wood flooring appear. Click on AutoGen to change it to a V-Ray material and select the polishedconcrete.vr matte file you just saved. Click the arrow to expand this section in the material browser. Now, we need to set the sample size, width, and height to 10 feet for a proper scale to that image file. Now, if you're using metric units, set these to 3 meters by 3 meters and close the dialog window. Change the current view to Render 2 for a better look at the floor and go ahead and render. Now, this gives us a pretty good but basic material. Let's work it to make it look more realistic. For one thing, the floor is quite uniformly glossy in its reflection, and another thing, real polished concrete almost always has a bit of a wave to its surface that we're missing here. Go back to the material editor. Instead of using a simple glossiness value of 0.85, we'll use a texture map instead. Click the map icon and then click on None and select the Noise Legacy texture. In this texture, the bright areas are more glossy and the darker areas are less glossy, where pure white is a value of 1 and pure black is a value of 0 for the glossiness. Now, what we have is currently too extreme, so I will adjust the color A to be slightly darker and set color B to be much brighter, but still darker than color A, to create a more subtle range in the grayscale. Change the type of noise to Perlin to change the pattern of the noise that is generated on the floor. Click back to get to the material again, and you'll see just a bit of difference in the preview now. Let's now define a bit of that waviness to the concrete surface using a bump map. A bump map is a grayscale texture that gives the illusion of surface undulation or perturbance when it's rendered. Basically, it's like creating bumps on a surface without having to model that detail into the geometry itself. Now, bump currently only works with textures and not image files, so we'll select the Noise Legacy texture again. Leave the values at default for now and click back. Back in the material, the bump value regulates how much the bump texture affects the floor. At a value of 1, the floor could undulate up and down according to the noise pattern about a foot or so, which would make any homeowner go crazy. So let's set it to a low 0.03 for a very subtle waviness to the floor, then click the checkbox to enable the bump. It's such a slight amount, you probably won't notice a difference in the preview, but will definitely see it in the render for sure. Save the material with File Save to replace the previous polishedconcrete.vrmat file, which is already assigned to the floor in the project. In the VFB, select a region to render the floor and click to render. The bump texture has created a slight waviness to the reflection in the floor, and you can see a subtle variation to the glossiness of the concrete as well. This gives us more of a realistic concrete flooring than we had before we added the glossiness and bump textures. Turn off Region Render and set the current view back to Render 1. Change Quality to High and change the resolution to a DPI of 150 and render your view. Give the render a little time to resolve to a cleaner image, so we'll go ahead and elapse the time here to finish with a pretty nice render of this glass table and floor. When you're satisfied with your render, click Stop and there you go. Thank you for joining us for this quick start video on the material editor for V-Ray for Revit.